apologize, my sound somehow not working. But your time is up, so colored pens ready. And what did we get for number 1? We'll start with Hezekiah, Eric, and then Alicia. Okay. Okay. There is no solution for number 1. Number 2, what did you get? Start with Shelby, Sharik, and then Brian. Okay.
X equals 1 and 3.
Okay. X equals 1 or... Okay. The correct answer is x equals 1 or x equals 3. So, let's start with number 1, because I'm going to survey separately. Give me a thumbs up if you got number 1 correct. Good, put your thumbs down. So, if you got number 1 correct, I'm pleased, and I'm not even worried about number 2. In fact, I got number 2 from a section in my extra resources that I get with books that's called the challenge section. And this is actually above and beyond what you were taught, and it's above and beyond what you have to know. I wanted to see what you would do. So, I was hoping you would treat it just like you would treat it if this were a number. So I was hoping you would see it the same as if it was like that. If you treated it exactly the same as that, then you should have gotten those 2 solutions. It's just a little bit more complex. What that means is, once you have the absolute value isolated, you have to then rewrite it as 2 equations. 3 minus 2x equals x. And then it's going to be 3 minus 2x equals, Sharik?
The opposite of x.
The opposite of x, or negative x. Now solve both of those. Add 2x to both sides. And you get 3 equals 3x. That you can solve mentally. Add 2x to both sides. This cancels out, and you get 3 equals x. So, when I was trying to decide on what types of questions to do in today's warm-up, I decided I wanted to push it a little bit. I wanted to challenge you. So again, this was beyond what you were taught. But, conceptually, you should have been able to have some idea of what to do. Okay? Comments, questions on either of these? Let's start with Anissa. Yes, I saw that. What if you had what? What do you mean? What number? What if I put a different number here? Oh, when I erased this and then I drew in a number? I was just trying to explain that when I taught you last time how to do this, the only examples we ever did had numbers here. That's all I was trying to show you. I'm not saying that x is equal to 3. Maybe I used the wrong number. What if x was what if I put a 10 there? So how would you solve that? That's my point. That was last lesson. What I'm saying is, if there's a variable there, then you actually treat it exactly the same. Okay? Good. Question or comment? Other questions, comments? Good. Today we're going to explore the idea of an absolute value inequality. So just to refresh your memory on the sequence that we've gone through in Chapter 6, we learned how to solve inequalities. Then we learned how to solve compound inequalities. That was the big leap. Then last lesson we learned how to solve absolute value equations. Now we're going back to inequalities and combining that with the idea of the absolute value. it's going to seem a bit confusing. But here's the interesting thing about absolute value inequalities. They are actually compound inequalities that are just hidden. Let me say that again. They are compound inequalities that are hidden. So the only new thing today that you need to learn is how to find the hidden compound inequality. Once you can do that, you will be highly successful. This group took a quiz on 6.1 to 6.4. 6.4 was where we studied compound inequalities. You guys did phenomenally well as a group on that quiz. That tells me that you guys are very good at compound inequalities. So today, you should be very successful. It's just a matter of finding the hidden inequality. So here we go. I've broken it down for you as a sequence of steps. Step 1 is the same thing that we did last time. This was new yesterday, or the other day. Isolating an absolute value. So we're going to do the same thing again today. Everything happens once the absolute value is isolated. Here is the new part. Then we rewrite it as a compound inequality. So step 2 is the secret. Step 2 is where we find the hidden compound inequality. And here's how you know. If the inequality, after being isolated, is a less than one of these symbols, then we rewrite it as a compound inequality with the word and. If it's a greater than symbol, then we write it as a compound inequality with the word or. I have a memory system for you to use. That's what these stars are going to show. I'm going to show you in a moment. I have a memory system for you to use that makes it really easy to remember which one is which. I'll get to that in a moment. After we write it as a compound inequality, you already know what to do. You guys proved that on the quiz at 6.4. You solved the inequality. So, what's the memory device? Here it is. To remember which compound inequality to turn it into, you're going to use these silly words, gore, land. You can think of it as one word or a hyphenated word or two words. It doesn't really matter. Here's what it means. Gore. The G stands for greater or greater than. A greater than turns into an or. Land. The L stands for less than, and a less than symbol turns into an and. So what I would hope you would do is commit this memory device, and it's not going to be hard. Commit it to memory, and then whenever you have to deal with absolute value inequalities, write down the memory device, and you'll be able to figure things out pretty quickly. So, this may make no sense to you so far, and that's okay. In a moment, it will make perfect sense. Does anyone have any questions so far? Yes, and then yes. Bless you.
So for the absolute value inequalities, you write it as a compound inequality. But why can't we just solve it? Why don't we solve it like absolute value equations? Why is it that you have to rewrite it as a compound inequality?
You could. There is another approach to this, which is almost the same. In fact, I used to teach it slightly differently. But this way, actually, to me, makes quite a bit more sense. I'll show you the other way individually later on. No. Okay, so today's lesson, we are not starting with the most complex and then working to the less complex. Today we're starting simple because I need you to focus on this part right here. So, example 1. I would like all of us to be able to solve this absolute value inequality. So it says the absolute value of 5x minus 7 is less than or equal to 23. That is actually a fancy, advanced way of writing a compound inequality. And so what I've told you so far is it's hidden. We just have to find the compound inequality. From there, it will be easy for us. So I'm going to write down my memory device over here just to help myself. Gore land. I'll get back to that in a moment. The first thing I have to do is isolate the absolute value. So how do I do that in this question? How do I isolate it? What? Do you agree with that? You don't agree with that? It's already isolated? What do you think? Now you see that it's already isolated? Good. So it's already isolated. So we don't have to do anything for step 1. Now step 2, now we're going to use this memory device. And the memory device depends on this symbol right there. So are we going to rewrite this as an or are we going to rewrite it as an and? What do you think, Kayla? What did you think, Catalina? Yeah, because it's a less than symbol, L, and. So you should remember that a compound inequality that's an and looks like this. And the x is in the middle, and then we have a number on the left and a number on the right. So we have to translate this into this. First thing we do is we drop the absolute value symbol because we're rewriting it. This expression goes in the middle, 5x minus 7. This is going to go right here, just like it is already. So that's going to be a 23. So we just have one thing to fill in, and you should already know what to put. I'm not going to say it's super easy to know, but you should know. What do you think we're going to put on the left-hand side? Brandon? Ania, what were you going to say? What were you going to say? 6? How come? Okay, you just thought of a 6? Okay. So any other suggestions? Come on. 7, how come? Okay, good thought. Okay. So Brandon was right. And it just has to do with what you learned last time. When you're solving an equation, you write 2 equations, right? And one of them, the answer is positive, and the other one, the answer is negative. That's what you learned last time. So here's where we're using that idea. So this is going to be a negative 23. Now we have it set up as a compound inequality. Now we solve it the way you learned a couple of weeks ago. So how do we solve? What's the first thing we do? Tristan? Good. Add 7 to all sides. This will disappear, and then I'll have negative 16, 5x, and 30. But since I'm dealing with inequalities, I also have that special inequality rule kind of floating in the back of my mind in a big banner. What's that special inequality rule? Jada? Very good. You always have to have that running in your mind. But I did not multiply or divide by a negative number, so I don't have to worry about that yet. What's the next step in solving the inequality? Good, we got lots of confident people. Shelby? Elisa, do you agree with that? Oh. What was it again? Okay. I'm going to bet a lot of money that she still didn't hear you, but that's okay. What do you think we should do? Good, yeah, we're going to divide all sides by 5, and that is what Shelby said. We're going to divide everything by 5. That's what will isolate the x in the middle. And you can rewrite that as a mixed number, an improper fraction, it doesn't really matter. Negative 3 1/5. And now, did we multiply or divide by a negative number at any point?
No.
No, so we don't have to flip any signs. And we have successfully solved the compound inequality, which in essence means we solved the absolute value inequality. So just to clarify, All of this right here, you already knew how to do. Everything that I wrote in bright blue and purple, you already knew how to do. The only new thing was how did we get from here to here? That's the only new thing you're learning today. Okay? Brandon.
The first one, so everything in that, like, everything between -3, 1, and 106 have solutions to the first equation.
That's right.
And then, are we going to have to graph it?
We will. But I like what you said, that every number between this number and this number will make this a true statement. That was a great connection that he just made. That's really important. Every number in between -3 and 1/5 and 6 will make this true. Every other number will make this false. Okay? Right.
You could also solve the absolute value inequality by treating it as an equation and separating it into two and find the answer and put it back into.
That's right, and that's actually how I used to teach it. And I decided recently that to me, this makes more sense because it connects with what you already learned more easily. But you are absolutely right. You can treat it like the equations we learned yesterday, solve them separately, and then use Gorland at the end. I'm not going to really get into that because I don't want to confuse anybody. Yeah.
You know how last time you said that if the number on the right is negative, it can't work because it's a distance? Is that still working in inequalities?
Yes. Very good. Eric.
I really don't get how Gorland
Gorland
is.
is just what's telling us whether to translate it into an AND inequality that looks like this, or an OR inequality that looks something like this. And don't write this down because I'm making it up off the top of my head, but x minus 1 is less than 3, or x minus 1 is greater than 16. I'm sorry, I didn't leave enough room. That's an OR inequality that you learned in 6.4. That's an AND. This tells us which one to rewrite it as. You didn't see any of these yet. I only did one example. You got to give me time to teach everything. Okay? So,
It's lunch.
so part B. And I'm going to grab my Gorland here. So part B, again, still just trying to understand step 2, the process of converting the absolute value inequality to its hidden compound inequality. The first step is to isolate the absolute value, as we discovered in the first example. I've eliminated that step just for these first 2 examples so that we could focus on step 2. So it's already isolated. Now we need to convert. And it's all based on the symbol. So which type of compound inequality is it going to convert to this time? Sebastian? Yeah, it's a greater than symbol, G, so it's going to convert to an OR. So this one's a tiny bit harder. So here's what it is. We're going to drop the absolute value symbol. So we've got x minus 9 is greater than 1. Or, now we need a second one. It's going to be the same expression on the left, x minus 9, but the rest is different. You should have an idea of what it will be, but it's not as easy as the other one we did. Zabari? Yeah. It's going to be less than -1. This is similar to what you learned in the last lesson about writing the absolute value equation as 2 equations. And the answer to one of them is positive and the answer to the other one is negative. But now when you talk about an inequality, we have to flip the symbol. And it actually makes perfect sense, and you'll see why in a moment when we get to our answer. Okay? So now we solve both of them just like you learned, and they're connected with the word or. This one's very basic, it's a one step. So add 9, and add 9. And we get x is greater than 10, or x is less than 8. Now, so none of this was new. If I just gave you this and I asked you to solve it, no one would have any trouble. Because we proved that on your last quiz, everyone's an expert at that. The question is how did we get from here to here and why? Because the hard part is this right here. Why is this symbol flipped? I don't have a great explanation as to why it's flipped, but I do have a good reason why. I'm sorry, I don't have a good explanation as to the root of why it's flipped, but I can show you what happens if we don't flip it, and then you tell me if that makes sense. So if we don't flip this, so I don't want you to copy this down, I just want you to pretend for a moment that we don't flip that, which means that this answer would really be x is greater than 8. Look what happens when we graph that, and I'm going to graph it very quickly. Here's 8, 9, 10. Look at what happens. What's an OR inequality supposed to graph like? It's supposed to be opposite ends, right? So it should be graphed here and here, but read this. This says x is greater than 10. So that means that here's what my graph would look like. Greater than 10, right, is all of this. Now watch what happens if I do this one. X is greater than 8. Does that seem to make sense? Doesn't really make sense, especially because of this right here. It's like crossing over that. So in actuality, this does not make sense. This makes perfect sense. Because when you graph it, it actually graphs as the opposite ends. It graphs here and here. So we have to flip it. Okay? So, if you're struggling with the why, I can appreciate that. So that means that you just have to do it. In other words, you have to do it whether you understand it or not. So, let's review. With an AND inequality, we write the exact same inequality, but then we add on this end to it, and we make the number negative. So that wasn't too hard for us to understand. For an OR inequality, we rewrite the exact same thing without the absolute value symbol, add the word OR, then write the exact same thing again, except we flip the symbol and flip the sign of the number. Okay? Does anyone have any comments or questions? Comments or questions? Concerns? Tristan?
And will there be any equations that have both of the equality signs facing?
There is no such thing, and I did feel badly for some of you on the quiz who did get that one question wrong. There is no such thing, there is no such thing as that or that. Those don't exist. Okay? That's what you were talking about, right? Facing in? Yeah, these don't exist. Okay? Good. So let's see how you do on your own. So I expect a moderate level of success so far. Checkpoint number 1. You got 2 minutes. If my sound doesn't work, which I don't think it is working, I will just let you know when your time is up. Take another 30 seconds to finish. All right, so let's see how we're doing so far. What did we get as our solution? Start with Ania, and then Catalina, then Hezekiah. Ania, what'd you get? Okay.
X is greater than or equal to -16, or X is less than or equal to -16.
Okay. Hezekiah?
X is greater than or equal to 16, or X is less than or equal to
Okay. So we have 3 different answers floating around. Zabari and then Brandon. Zabari, what'd you think?
X is greater than or equal to -16, or X is less than or equal to -16.
So that was the same thing as somebody said. Okay. Brandon, I'm sorry. So what was yours?
X is greater than or equal to 16, and X is less than or equal to -16.
Okay, well, that had some major issues with it. The correct solution is x is less than or equal to -56, or x is greater than or equal to -16. Yes, you have the same thing, but the other way around. That's the same thing. But I did teach you that the smaller number should, if possible, go on the left. Okay? Yes? Okay. I understand. That's an honest mistake. Okay? Catalina. So you had the same thing except you said positive 56. Now, that's fine. You just made a small, tiny little mistake. But here's the thing with that. And here's where my conversation with you the other day about getting a 5 on the EOC comes into play. Because now you have to think about your answer. Does your answer make sense? Picture the graph of yours. The graph of yours what will that look like? You said x is greater than or equal to negative 16, which is shaded this way. And then you said x is less than or equal to 56, and 56 would be all the way over here, which would go that way. But which way is an OR inequality supposed to be shaded?
Yeah.
Outsides. So something is not right here. Something went wrong. An OR will be shaded over here and over here, not in the middle. This is an AND. So something's wrong here. So when you do it correctly, so this is incorrect if you graph it correctly, the negative 56 is the smaller number, the negative 16 is here, and then you see that you shade out here and out here. So it's great if you can work through a question and you have a good idea of what to do, but now what's the next level? The next level is now I can look at my answer and then decide if it makes sense. That's the next level that we have to achieve. Okay? Comments, questions?
I was just wondering, is there ever going to be an OR inequality, for example, that would say x is greater than or equal to 1, or x is less than or equal to 1, or x is greater than or equal to 1?
Well, graph it and you see what it looks like, and that'll tell
I already
you.
did.
Okay. So, okay, we'll talk about that in the future. You are going to see some unusual cases, but usually it's going to work out where the AND is in the between and the OR is on the outside. Okay? Good. Any comments or questions or concerns? Remember, we're still learning, so it's okay. All right, I'm going to move on. Example 2. Now, I'm going to add back step number 1. I eliminated that so we didn't have to worry about it for the first few times. So step 1 tells us that we need the absolute value by itself before we can proceed. So that's what we need to do. How do we achieve that goal in this question? Caleb? Do you agree with that, Sharif?
Wait, she said, what did she say?
I don't know. What did she say? Oh, okay. Go ahead, Caleb. What do you think we should do? Do you think that's what we should do?
Yeah, subtract 4 from both sides.
Good. So we'll subtract 4 from both sides. Excellent. This will disappear. And now we've got the absolute value of 3x minus 3 is greater than or equal to 6. Step 1 is done. Step 2 is the new material. Now we convert. But I need my little memory device to help me along. So is this going to be an or an and? Which one is this going to be? Anissa? You agree, Tristan? Yeah, it's going to be an or. So now I have to pay attention to my details. So we've got the same exact inequality with no absolute value symbol. 3x minus 3 is greater than or equal to 6. Or, same exact left side, 3x minus 3, but now everything else flips. The symbol flips, and the sign flips. And now I have converted, using Gorland, I've converted from this to this. Now the rest you already know. Solve both of them. How do we solve? What's the first step going to be for both of them? Go ahead, Anissa. Yeah, we're going to add 3 to both sides on all of them. add 3. We'll just get a different result. So we get 3x is greater than or equal to 9, and we did not multiply or divide by a negative number. And here we get 3x is less than or equal to negative 3. And we're not going to multiply or divide by a negative number, but we can do mental math. We got x is greater than or equal to 3, or x is less than or equal to negative 1. And now I need to ask myself, does that seem to make sense? And what you'll notice is that the less than symbol should go with the smaller number. That's usually what's going to happen. That's what's going to make the left side get shaded, and this is what's going to make the right side get shaded. So, in my mind, that seems to make sense. Okay, Kezekiah? Okay, so the best thing to do, the best answer is to flip it around so that the smaller number is on the left. So that's why I have encouraged you to do this. X is less than or equal to negative 1, or x is greater than or equal to 3. And that is by far the best answer, and you're going to see why in a second, because in this question we are asked to graph. So, we need a number line and now you'll see why this makes more sense the way Kezekiah said it. Because the smaller number's on the left, and of course smaller number's going to be on the left. Negative 1, 0, 1, 2, 3, 4, 5. And now I'm going to have a closed circle, a closed circle on the negative 1, a closed circle on the 3, and now I'm shading the opposite ends, the outsides, just like Catalina had said earlier. So this part of the OR matches this part of the graph. This part of the OR matches this part. If I write it like this, it's not incorrect, but it doesn't really match. Okay? So, comments, questions on any of this? Concerns? Okay, so one more before you try on your own. So in this example, parts A and B, the difference between these two and the previous 3 questions was that the absolute value is not isolated, and so that's something we need to do. So we subtract 5 from both sides, and that will start to accomplish the goal. This will disappear, and we're left with this. Now, someone had mentioned earlier, and I think it was you, Catalina, that if we get a negative, or maybe it was Eric, I don't know, someone over here had mentioned, if we get a negative number on the right-hand side, does that still pose a problem with an inequality? And it does. But the thing is that that's only true if we've isolated the absolute value. We have not isolated the absolute value yet because we did not get rid of that. So we do have one more step to go. How do I get rid of that negative 2? Alicia, how do we get rid of that? Do you agree with that, Sebastian? Divide both sides by negative 2. So now we're left with this. Something just happened. Something small yet important. What small yet important detail just happened, Anne? So what do we have to do? Yeah. So I mean, think about all this. You got to keep track of all these different little details, and if you miss one of them, you get the whole thing wrong. But that's what makes Algebra 1 Honors such a challenging class, is you do have to pay attention to all these little details. Okay? But here's the other thing. Using Gorland, excuse me, originally it looked like a less than, which would be an and inequality, but then through the process it turned into a greater than, which is going to make it an or inequality. So you have to pay attention to that. You don't use Gorland until you have the absolute value isolated. Now we are ready to rewrite it as a compound inequality. Now we've got 6x minus 1 is greater than 1, or 6x minus 1, and now everything flips. Flip the symbol, flip the sign. Now solve it like you were taught. Add 1, add 1. First step's always going to be the same throughout. The result will be different. 6x is greater than 2. 6x is less than 0. And so you can use mental math. We get x is greater than 1/3, or x is less than 0. And again, as Hezekiah pointed out, there's nothing wrong with that, but I did teach you that the smaller number should go on the left. And 0 is smaller than 1/3, so x is less than 0, or x is greater than 1/3. And that is the best answer. Does anyone have any questions? Now, I am a little bit short on time. We're supposed to graph this, but I'm not going to. I'd rather you have a chance to work independently on a question. So I want you to solve. I don't want you to graph. So go ahead and solve number 2. And you got 2 minutes. Again, I apologize, my sound is not working correctly. We have 20 seconds to finish up. All right. So what'd you get? 1, 2, 3, 4, 5, 6, 7, 8, 9 confident people, 10 confident people. Start with Aliana, Alyssa, and then Catalina. What'd you get?
X is less than or equal to 7, or X is more than or equal to.
Okay.
X is less than or equal to -7, or X is greater than or equal to 2.
Okay, that sounded similar. I think one number was different sign. What'd you get, Catalina?
X is less than or equal to -7, or X is greater than or equal to 2.
So there is some agreement. X is less than or equal to -7, or X is greater than or equal to 2. Comments or questions? Actually, let me survey first. Give me a thumbs up if you got it right. A lot of people. Good. Put your thumbs down. Come on, you had a comment or question?
Yeah, I got the same numbers, but I got
Okay. So based on what you've learned, which type of inequality is this supposed to turn into? It turns into an OR. And so you ended up, after you isolated the absolute value, you have 2x plus 5 is greater than or equal to 9. Is that what you had? Okay. So from there, the first thing we're going to write is this exact same thing except without the absolute value symbol. So 2x plus 5 is greater than or equal to 9. Let's for the moment forget about the other part. Let's just do this part. So we subtract 5 from both sides. Is that what you did? You get 2x is greater than or equal to 4. So divide by 2, you get x is greater than or equal to 2. So how come your symbol flipped? Well, that's the second part. Or, oops, I put that in the wrong place. Or 2x plus 5 is less than or equal to -9. But I'm still asking, you're telling me your symbols were the opposite. Why did this symbol flip? We didn't flip the symbol here. The first one you write down is the exact same thing, except without the absolute value symbol. Okay, let me come take a look at what you did, because I'm a little confused at what happened. Okay, so let me just take a look at it. All right, so now you need to put your pencils down, because we're not going to be able to work through number 3 together, but I just want to introduce the idea. So please take 30 seconds and read example 3. Do not write anything. So the real-world examples you're going to be dealing with again today are absolute deviation questions. So this is the clue that it's an absolute deviation question. The last time we did absolute deviation equations, now we're doing inequalities. It's the same thing. So you have to go back to the formula, and so you will be able to see the formula when you need it. But it was, it was the absolute deviation, and I'm just going to use AD as an abbreviation. Absolute deviation equals the absolute value of x minus the given value. What is going on? Given value. So that was a formula that we talked about last time. And you just had to figure out which number went in the right place. But now we're being asked to write the same thing except write it as an inequality. So you're going to have to decide which way the symbol goes. Is it going to be that, 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 or that? And so it's going to take a tiny bit of thought. But once you have it set up, then you just follow what you learned today to solve the inequality. Okay? So I'm not saying it's easy. I'm not saying that I'm happy on skipping over this. It is important. But in the interest of time, I just wanted to introduce it. Okay? So, draw a line across your paper. Everyone will get a free point for classwork. Your homework is page 409, numbers 10 through 28 even, and number 38. And yes, you are reading that correctly. The second page is page 904, numbers 39 to 42 all. Don't accidentally write the word even. Don't write the word odd, write all. That's a review section in the back of the book. So what I'm having you do is do small little bits of review for your semester exam built into your homework for the next few days. So I'm just going to review a few concepts. And so you're doing 39, 40, 41, and 42. Overall, it's only 15 questions. And I already explained on my whiteboard